Unmute my microphone. Yeah.
Yes, I can see you on the YouTube channel.
Okay.
Okay, yourself and good to go.
Unmute my microphone. Yeah.
Yes, I can see exactly.
later. So, you can access the LDE lights, you can access the pulse, it's quite a lot later. Yeah. So, you can access the LDE lights, you can access the pulse, it's quite a lot later. Yeah. So, you can access the LDE lights, you can access the pulse, it's quite a lot later. So, you can access the LDE lights, you can access the pulse. So the other development boards for embedded systems is the Arduino Nano, which I think we are going to, for this particular session, this is what we are going to really use. The learning challenge is going to use. So again, this is a development board that is based on the RP2040 microcontroller Nano with the form factor. It definitely supports MicroPython. Some of the peripherals on this board include Bluetooth sensors, the UART. The UART again is used for communication. You can still access the memory. It has about 246 KB of RAM, 16 MB flash, and then also it has bit of the U-Blocks radio module. Again, now that comes into the communication bit, which I told you will need to take a session on LP-LAN, and then supports Wi-Fi. Again, as you see from the other previous session that I talked about, you will understand. I also took out its pinout diagram and showed you, a bit of a small sample code at the side to say that, hey, okay, so if you, for example, in MicroPython, you say import machine as a library, then you can actually say machine.pin29, which means that you're actually accessing one of the GPIOs on the specific board. But you can definitely access a lot more. But the basic understanding is that, okay, MicroPython is used to access the peripherals, some of the peripherals that are on the board. And again, we come back and we talk about the microcontroller processor. This one is based on the Raspberry Pi RP40 silicon, and also you see that ARM is still involved, as they are the ones that actually design the microcontroller. Included are also its data sheets to help you begin understanding the board that you're working on. Importantly, because it is important. Why? Because how do you program for something you don't understand? That for me is the reasoning why, and also based on your responses, why I'm including this in the session. And you can also, get a little bit understanding of the semantic diagrams, and you can also learn, a little bit of how you run MicroPython on this. Then the other development board is, the Raspberry Pi Pico. You should also know that it's also another controller board with the wireless capability. Definitely supports MicroPython, but it's running a dual microprocessor, another different processor, microcontroller processor, which is a controller, which is a dual core ARM Cortex, but also it has its GPUs. It's also peripherals, which you can by using MicroPython, you can still access and use and access the peripherals. The other development board, the one that I have specifically, and the one that I will be using will be a combination of the two. It will be the PySense from Pico and the PhiPi. We will combine these and then the antenna. And then yes, from PhiPi, we'll combine this to in the next coming sessions. We'll combine both of these so that we read data from the PySense. The PySense has I think something like 6-7 sensors. We will read data from the PySense, and then we will be able to transmit this data via the PhiPi, which is actually running the microcontroller processor, which Python will be the MicroPython will be running at, and then will be so in the next sequence. In the next coming session, we're really going to do this practical, and we're able to access some of the some of the components, some of the measurements, some of the peripherals on the board, and then we will be able to manipulate that. I've also included, more data if you wanted to read more about this microcontroller. I've also included the references therein. Yes, so what's going to be expected in the next coming session? We're definitely going to do a demo on MicroPython and PySense and PyPy. Now that we have an understanding of what microcontrollers, the different types of microcontrollers, what they are, what their peripherals are, what things are we going to be, what kind of things are we going to be accessing on the board? Now that we have, then the next we'll have an introduction on LP1 networks, because once the data is collected, once you can access you can access the accelerometry, you can access the sound. For example, the microcontroller for Raspberry Pi, the RP2040 has, a microphone. So once you can access that and you can access the signal, then what do you do with it? So once the data is gotten, then how do you transfer it? We shall have a demo, and then later we can have a demo on the ML edge deployment on PyCom and PyBytes platform, as we wait for some of the as we wait for ARM to have platforms and so forth, and then I definitely will also demo the setting up and running of a LoRa network via TTN, and setting it up via the LoRa gateway from PyCom. Definitely also, in order that the next coming sessions to be easy for everybody, we'll need to do, I will need at least some understanding of the electrical components of the board, that to improve the understanding of of what the boards are entailing, and so I would like some bit of reading up on some of the components on the board, and so that you widen your knowledge base in terms of what it is that we are doing and how we'll be moving forward. Yeah, and for more references and extra reading, please, I've included that. I've included these details, and you can follow them. So basically, in a nutshell, today, based on the responses that you've given me, was to show you in this industry, how wide is in the industry, first and foremost. What can you do once you have obtained this knowledge? Not only machine learning, but electronics design, network design, software design, and then especially is that if you're going to be on the software part, then you understand the target machine for which you are writing that software for. It doesn't make sense to simply deploy a model when you don't know what kind of size that the microcontroller is able to handle. So the more you understand the microcontroller, then the better software you will be able to write. So now that you have an understanding of what microcontrollers are, or if you don't, you can still go fundamentally read still about them. Then now the software bit and the MicroPython bit, which is going to come in the next session, that is the easy bit. But when these are not grounded, then there are challenges, because you quite do not understand the capabilities and the limitations of the board and what you can do, or the microcontrollers, and what you can do with them. So, peace. I think that is all. So thank you.